In this video here, we're going to learn the simple step in graphing for logarithmic functions. In these techniques here, it consists of 5 steps where we can remember the 5 steps based on the first letter on the simple step in graphing, which correspond to first, step 1, the type of the functions. Second, the shape of the graph. Third, special points or special line corresponding to the functions. Fourth, the intercept on x and y axis, or we call it the x and y intercept. And at last, we go for sketching the graph. So in here, just quickly go through the log functions that we're going to discuss here for the sketching later. It will be a log functions that we only have x term inside the content of the log, and the x term here supposed to be a linear expressions. And other further details we will see further in step 1 here for the type of functions to have a better idea. But basically, we're discussing log with linear expression within it, and the rest of the part should be just consist of constant. Follow. Step 1. The type of functions. So, as we said just now, I just would like to have the log with the content here as linear expressions, and also the a here, we want it always to be a constant which is greater than 1. For examples, we have fx equals to 1x, where the 1 here is actually base e is greater than 1, log to the base 2 greater than 1, base e, base 5. And what if, like the last example here, if I have the base is less than 1, what we do? We change base. Where in this case here, how the thing is happening is that from 1 over 4, we change the base to, we just simply take this value here, 1 over 4, we have it change it to 4 over 1, and it gives us the idea that I want to change to base 4. So therefore I go for log base 4 over log base 4 for x, and 4 to the power of minus 1. 1 over 4 is 4 power minus 1, and as a result, this is the result that we have now. And as you can see now, it fulfills the form that we want for the type of functions here, for around the base number here greater than 1. The reason why we want to have this thing here achieved, so that later when the time we determine the shape of the graph, we will not have so much of unnecessary problem and mistake. So now, in this table here, I would have each of these functions here list down the corresponding capital A, small letter a, m, c, k with the general function to observe what is going on, that we say that they are the function that come in this form here. And among all these letters here, I would like to emphasize on the capital A and the small letter m here, which is important later for us to refer the shape of the graph, where a here is referring to the sign on the function log, where we want to know whether we are having a plus log or minus log, a plus or minus functions. And the m here is corresponding to the coefficient of x, which I would like to know whether I have the case of positive x or negative x to determine the shape of graph later. So let's see the next slide, the shape of the graph. So basically, for the shape of graph here, we have 4 form of graph, 4 form of shapes, and we will begin with the first shapes as the foundations, where this is the first shape here. The red dotted line here is corresponding to the vertical asymptote, and a greater than 1, m greater than 1 is corresponding to when the time I have the case of positive log, with the base a here greater than 1, and then I have also m greater than 0, which is corresponding to having positive coefficient on x. Then this is the shape of the graph that I have. And to have a better idea, let's see the examples of the functions, like what you see here. For the x term, all the coefficient is positive. This is what I mean by positive x. The coefficient is positive. Then the next one, you see the log. It is always having positive sign in front, where you don't see negative sign in here. That means it implies that there is positive. Next, what if now, if I have the case that from log and also x, one of them I happen to change it to negative. For example, let's say I have the x here, I change it to negative coefficient of x, but I have the case of positive, maintained as positive function log for the case a greater than 1. What will happen to the shape of the graph that I will have here? Let's see. So the shape of the graph will just happens to be, we flick it horizontally. By the time you change the sign on the x, it will happen to flick horizontally. And the corresponding examples, as you can see here, all the log is still positive. The log still have positive coefficient. The x now have negative coefficients. So whenever you change the sign on x, in terms of the shape of graph, you'll see that the graph will flick horizontally. Whereas, if let's say now I have another situation, again, instead of having plus plus for both log and x, if let's say I would like to have the case that now I change the sign on the log to become minus. Again, this is for case a greater than 1. The x maintained as positive for the coefficients. So, how's the shape of the graph will look like? Let's see. It will happen that we flick the graph vertically, and this is the form of graph that we have. And once again, the a less than 0, m greater than 0 is corresponding to the coefficient of the function and also the x. And once again, we compare here, you can see all the x coefficient is still positive. All the coefficients of log is negative. So this is the shape of graph. And finally, if let's say both of the log and also the x terms come with negative coefficient, so we have negative log for a greater than 1, if we have negative x, then what will happen to the shape of the graph? Let's see. So if you have point of view from this graph here above, from plus log minus x change to minus log minus x, then from this graph on top to the new graph here, it will happen to be considered flipped vertically. If I consider from the graph on the right, from minus log plus x change to minus log minus x, what will happen is that I will need to consider it flipped horizontally, and as a result, this is the shape of the graph that I should have. And once again, the capital A and also the m less than 0 indicates that the coefficient of the log and also the x. And once again, we see the list of example at the side here. We can see the x come with negative coefficient, the log also come with negative coefficients. So this is how we determine the shape of the graph. Next, let's see step 3. In this case here, for the function of log, we have a special line, which is the vertical asymptote, which is this dotted line here. This green dotted line here is the vertical asymptote. And how we find out the answer for the vertical asymptote is basically just that we take the content inside the log here, make it equal to 0, we solve the x, that will be the answer. The vertical line that we obtain from mx plus c equals 0. So for the first examples here, if let's say I have fx equals to ln x, so we just take the x equals 0. So the vertical asymptote is x equal to 0, which corresponding to y-axis. The next one, x plus 3 equals 0, so I have x minus 3. 1 minus 2x, we have x equals to 1 over 2. 3x plus 1, I have x equals to, so in here, I think there is a slight mistake. It's supposed to be negative 1 over 3. And the last one, it will be x equal to 0, the y-axis as well. Okay. Then for step 4, after we have reached until step 3, we should go for step 4 to identify whether x and y intercept exists or not, and what is the corresponding value. But before we go for step 4, just want to remind you, by the time you reach up to step 3, we can just roughly observe from the rough graph here, the rough form of graph here, together with the special line, to identify what is the domain and range. And we will discuss this later in an example to have a better visions. Now, go on step 4. We would like to identify what is the x and y intercept, and in this step here, I would like to have a rough sketch to observe whether do I have the x and y intercept exist or not? If they exist, then we try to find it by calculation or just solve using calculator. If they exist, if they doesn't, we just ignore the calculations. Then at last, combine all these informations. We go for the graph. And in the graph here, make sure you always label the coordinate x, the coordinate axis, x and y axis, the origin. Name the graph. If let's say it happens to be function f, so we name the graph as f, the vertical asymptote, and also the y and x intercept if they exist. So this is the intro for the case of log functions.